Have you ever stopped to wonder how your weather app actually knows the forecast? Or how you can use Sign In with Google on some random website? Well, the secret sauce behind all of that is APIs. They are the invisible engines powering, well, pretty much our entire connected world, from your favorite apps all the way up to global financial systems. So, let's get into it. So, here's our game plan. We're going to start with a really simple analogy. I'm calling it the digital waiter, to get a handle on what an API even is. Then, we'll look at where you bump into them every single day. After that, we'll dive into the different architectural blueprints, talk a bit about keeping them secure, and wrap it all up with why they're so critical to, the modern world.
All right, first up, the digital waiter. So, how on earth do all these different apps and programs actually talk to each other? Well, it all comes down to the API. And honestly, the best way to get it is to think about ordering food at a restaurant. Okay, picture this. You're sitting in a restaurant. You're not going to just barge into the kitchen and tell the chef what you want, right? No way. You've got a waiter. You look at the menu, that's the list of what's possible. Make your request, and the waiter takes it to the kitchen. A little while later, the waiter brings your food back. That waiter, that's the API. It's the go-between that handles all the communication, so you don't have to worry about the chaos happening back in the kitchen. And that, right there, leads us to the official technical term, API, Application Programming Interface. It's really just a fancy way of saying it's a software middleman that lets two different applications talk to each other. It operates on a very clear set of rules. It's like a contract that says, hey, if you ask me for something in this exact way, I promise to give you a response in this exact format. Simple as that. So, now that we've got the concept down, let's look at where these digital waiters are working all around us. And trust me, you are using them constantly, probably without even thinking about it. Every single time you click Sign In with Google, that's an API securely verifying who you are without ever giving away your password. When you open a weather app, it's using an API to ask a huge weather service, hey, what's the forecast for this location? Shopping online? That site is using an API from Stripe or PayPal to handle your payments securely. And those travel websites? They're an API powerhouse, pulling in flight and hotel info from hundreds of different airlines and chains all into one place. Okay, so we know what an API is, but they are not all created equal. It's like construction. You wouldn't use the blueprint for a skyscraper to build a tiny house, right? The same goes for APIs. Different jobs require totally different designs. Let's dig into the main architectural styles. And this is really the key takeaway here. The choice of which architecture to use, whether it's REST or GraphQL or something else, it all comes down to what the app needs to do. You have to ask, is this for the public? Does it need to be blazing fast? Is bulletproof security the #1 priority? The answer dictates the blueprint. This chart gives us a fantastic, high-level view of the 4 main players in the game. You can see how they differ right away. You've got REST, known for being simple and scalable. GraphQL for its amazing flexibility. Then there's gRPC, which is built for raw speed using something called a remote procedure call. And finally, SOAP, with its super strict, secure contracts. All right, let's break these down one by one. First up, the king of the castle, REST. Seriously, if you've ever heard developers talking about APIs, chances are they were talking about a REST API. It is, by far, the most common style out there, because it's built on the very same principles that run the entire web. So why is REST so popular? Well, it's pretty straightforward and it scales really well. One of its main features is that it's stateless. All that means is the server has no memory of you. Every single request is a brand new conversation. It treats everything as a resource, like a user profile or a photo that you can interact with using standard web commands like GET to fetch data or POST to create new data. This approach is just perfect for public-facing APIs like the ones from Twitter or GitHub. But REST isn't perfect for every situation. What if you need a lot more flexibility? Well, that's where GraphQL comes in. It was actually developed by Facebook to solve some of the headaches they were having with REST, especially for really complex apps. Here's the magic of GraphQL. Where a REST API might have tons of different URLs for different pieces of data, GraphQL has just one. The real game changer is that your app, the client, gets to be the boss. It can write a single, precise query asking for exactly the data fields it needs and nothing more. This means no more overfetching, where you get a bunch of junk you don't need, and no more underfetching, where you have to make a second or third trip. You can see why this is a huge win for mobile apps, where every bit of data counts. Now, if GraphQL is the precise surgeon, then gRPC is the Formula One race car.
It was developed by Google, and it is all about one thing: speed. It's designed for high-performance communication, especially between all the tiny internal services that make up a big modern application, what we call microservices.
Yeah, gRPC is an absolute speed demon. It uses the newer, faster HTTP/2 protocol, and instead of sending human-readable text, it sends data in a super compact binary format called protocol buffers. Think of it like sending a coded, compressed message instead of a long letter. It's way faster for computers to process. It also supports streaming data back and forth, which makes it perfect for real-time systems where every millisecond is critical.
And finally, we have the old guard, SOAP. Now, it might be the oldest of the bunch, but in environments where security and reliability are completely non-negotiable, I'm talking banking, healthcare, SOAP is still the undisputed champion.
SOAP is extremely structured. It uses a format called XML for everything, and it relies on this super formal contract called a WSDL. You can think of a WSDL as an ironclad legal document that spells out exactly how the API works, leaving no room for error. But its real superpower is its built-in enterprise-grade security. When you absolutely, positively cannot have your data compromised, SOAP is often the go-to choice. Okay, having all these incredible APIs is one thing. But with all this data flying around, how do we keep it all safe and prevent bad actors from messing things up? This is where we need to talk about the rules of the road. Security really comes in layers. First, you have transport security. That's the S in HTTPS. It's like putting your data in a locked armored truck while it's in transit. Then you can even have message security, where the message itself is encrypted, like we saw with SOAP. But maybe the biggest piece of the puzzle is access control, making sure only the right people get to make requests. This is where stuff like OAuth comes in, which is what powers those sign in with Google buttons. It lets you grant very specific permissions without ever handing over your password. And of course, you need to limit the rate of requests to stop your servers from getting overwhelmed. So how do you manage all of this? Well, in large systems, you use something called an API gateway. The best way to think of it is as a bouncer and a front desk manager all rolled into one. It's the single front door for every single API request. It checks IDs, that's authentication, directs traffic to the right place, enforces those request limits, and even gathers stats on who is using what, all before a request ever gets to your main system. It's absolutely crucial. So, let's bring this all home. Why does any of this really matter? Because APIs aren't just some nerdy technical detail. They are the fundamental building blocks of our entire digital economy. And because they're so fundamental, they are a massive target for attackers. Get this. A report from Akamai found over 85 billion credential stuffing attacks in just a 2-year period. That number is just staggering. And here's the kicker. 20% of those attacks were aimed directly at APIs. Securing these connections isn't just important, it's one of the biggest challenges in cybersecurity today. Ultimately, it really boils down to this. APIs are so much more than just code. They truly are the backbone of modern software. They're the essential connective tissue that lets thousands of different services and applications work together in harmony, creating the seamless digital world that we all depend on every single day. So now I want to turn it over to you. After going through these different blueprints, from the classic workhorse REST to the lightning-fast gRPC, which one have you actually used in your own projects? Or, if you're new to this, which one are you most curious to dive into and learn more about? Let me know.